What if an AI could look at its own work, decide it wasn't good enough, and then rewrite itself to do better? Not just once, but over and over, in a loop, getting sharper every single cycle. That idea sounds like science fiction, maybe even a little scary. But here's the thing. I actually built one. And in this video, I'm going to show you exactly how it works, what it got right, where it completely fell apart, and what that tells us about where AI is really headed. Stay with me, because by the end of this, you're going to see AI self-improvement in a completely different light. Let's start by killing a myth. When most people hear the phrase self-improving AI, they picture some Hollywood scenario where a machine quietly upgrades its own code in a dark server room and suddenly becomes smarter than every human alive. That's not what's happening. Not yet. What researchers and engineers actually mean when they talk about self-improvement in today's AI is something more nuanced and, honestly, more interesting. Right now, the most realistic form of AI self-improvement is what's called a feedback loop. You give the AI a task. It produces an output. Something, either a human, another AI, or an automated scoring system, evaluates that output. And then the system uses that evaluation to change how it approaches the next attempt. The AI isn't rewriting its own neural network weights in real time. What it's doing is learning from structured feedback to produce progressively better results. Think of it less like a machine upgrading its brain, and more like a student who grades their own homework and then tries again. Now here's where it gets interesting. I wanted to test whether this could actually work in practice. Not in a research paper, not in a lab with millions of dollars of compute. I wanted to build something real, with tools that anyone watching this video could access, and see with my own eyes whether iterative self-evaluation actually moves the needle. So I built what I'm calling a prompt optimization loop. Here's the architecture at a high level. I have a generator. That's the primary AI doing the actual task. I gave it a writing and summarization job, because that's easy to evaluate objectively. Then I built a critic layer, a second AI instance whose only job is to score the generator's output on specific dimensions: clarity, accuracy, conciseness, and relevance. The critic outputs a score between 1 and 10 for each dimension, along with written feedback. Then a third component, the optimizer, takes that feedback and rewrites the system prompt that the generator is using. So the next time the generator runs the same task, it's running under an improved set of instructions. Then we loop. Generator runs again, critic scores again, optimizer updates the prompt again. Repeat. I used affiliate software to build and orchestrate the whole pipeline. It made connecting these components dramatically faster than building from scratch, and the visual workflow builder meant I could actually see where data was flowing at every step. Now, let's talk about results. I ran the system for 10 full cycles on 3 different task types, and the improvements were real and measurable. On summarization tasks, clarity scores went from an average of 5.8 in cycle 1 to 8.4 by cycle 8. The optimizer learned that the original prompt was producing overly technical language for a general audience, and it kept tightening that instruction with each loop. On analytical writing tasks, accuracy held steady, which is good, it didn't hallucinate more, but conciseness improved dramatically. The outputs went from being padded and repetitive to crisp and structured. By cycle 10, honestly, the quality difference was stark. I'll show you a side-by-side on screen right now. But here's where I have to be completely honest with you. It wasn't all upward progress. The system hit a ceiling. Around cycle 7 or 8, the improvements started plateauing. And in 2 cases, the optimizer actually made things worse before stabilizing. What happened? The critic was working from the same base model biases every time. It had blind spots it couldn't see past. When the optimizer followed feedback on one dimension, it sometimes inadvertently hurt another dimension it had already improved. Without a human in the loop to catch these trade-offs, the system started chasing its own tail. This is the dirty secret of AI self-improvement that a lot of the hype glosses over. A system can only improve along the dimensions it can measure. If your evaluation mechanism is flawed, biased, or incomplete, your self-improvement loop will optimize confidently in the wrong direction. It's not just a technical problem, it's a philosophical one. You have to be able to define what better actually means before any system can reliably get there. So what does this mean for the big question? Can AI actually improve itself? My answer after building this is yes, meaningfully, within constraints. And those constraints matter enormously. Current AI systems can improve their outputs through structured feedback loops, and the gains are real enough to be genuinely useful in production environments. But they cannot redefine their own goals, rewrite their own architecture, or escape the ceiling set by their evaluation mechanisms without external input. True recursive self-improvement, where an AI improves not just its outputs but its capacity to improve, remains an open problem. Researchers at places like DeepMind and Anthropic are working on versions of this at scale, with techniques like constitutional AI and reinforcement learning from human feedback, which is RLHF. These are more sophisticated versions of exactly the kind of loop I built. The difference is the scale, the quality of the feedback signal, and crucially, the human oversight baked in at every stage. Now, what does this mean for you? If you're a developer, a builder, or just someone who wants to use AI more effectively, the takeaway is this. Feedback loops work. You don't need to wait for AGI to start building systems that get better over time. You can implement a simplified version of what I showed you today in your own workflows. Start simple. One generator, one critic, one loop. Measure what matters to you. Let the system optimize toward that metric. You'll be surprised how much better your outputs get with even 3 or 4 cycles. If you want to learn how to build AI systems like this yourself, from architecture to deployment, I'd strongly recommend the course I've linked below, Affiliate Course. It walks you through exactly the kind of pipeline thinking you need to go from idea to working system, and it's the resource I wish I had when I started. The bigger picture here is that AI self-improvement isn't some distant theoretical concept. It's already happening in limited practical forms right now. And understanding how it works, not the science fiction version, but the real engineering version, puts you ahead of the vast majority of people thinking about this technology. We are not at the point where AI is autonomously rewriting itself into something unrecognizable. But we are at the point where thoughtfully designed feedback systems can produce measurable, compounding improvements in AI output quality. That's genuinely powerful, and it's only going to get more powerful as evaluation methods improve and compute gets cheaper. If you found this breakdown useful, subscribe. I go deep on AI systems, automation, and emerging tech every week. Drop a comment with what kind of self-improvement loop you'd want to build. I read everyone, and I'll see you in the next one.